So for example, we also want to secure something we think important, right? So data is so important. Why don't we try to protect it? So that's why it actually lay out the foundation, and also why we are interested to work on cybersecurity. Earlier, we have done a literature review on the beam security or CDN security, and we have the relevant academic paper on this one published in AutoCon. So in summary, then we found that there are 7 areas for the beam security, and those can be tackled by like blockchain or the encryption technologies. For example, in terms of the data ownership, data sharing, model federation, information workflow, and also different layer of the security in data level, network level, and system level. So that's why we felt that actually it's very important that we try to integrate BEAM with blockchain, because in Hong Kong, BEAM is compulsory since 2018 for all the public projects exceeding 30 million Hong Kong dollars. So that's why we started our project since 2 years ago. And thanks for the help and support by LCM, by the Hong Kong government. We started a project on the security mine CDE for building data management using the distributed ledger technology. Basically, is blockchain. So the project actually took about 2 years, and then Dr. Momitas is the project coordinator. And so that's why in the following, I would like to quickly share with you some of the findings and then how it actually can link up to many different topics. And I would also like to take this opportunity to thank all the sponsors and also supported organizations for this project, particularly like Hipping Construction, City. They provide the actual site for us to test. So you know, academics, we have many theories, but many people think that we don't go down to earth for practicals. Not they. Okay, so that's why it's actually important to have some real project to demonstrate our prototype. And one thing we try to do is we try to use different technologies. For example, the encryption technologies or different kinds of encryption technologies. For example, we consider how we can re-encryption, or maybe some symmetrical or asymmetric encryption, so that we can tackle different needs of the data security. For example, confidentiality or integrity, access control, stuff like that. And then we also develop a distributed CDE. So basically the concept is we will allow different people have their own ownership for their own data, but at the same time they have a common chain of the signature of the information shared. And then through this one, then we have we put this chain in the blockchain platform, and what we use is the Hyperledger Fabric. We are also using the Ethereum, so depending on the needs of the project. And then the data actually are also put in the IPFS. So with this one, then we can apply to different applications, which I will very briefly share with you. For example, all the way from design to tendering to construction and all the way to FM. So for design, it is actually important that we have a trace or a track record of who have made the changes, because we keep doing changes. Then if there's any design problem, then we want to see who made that decision. No, I wouldn't say problem, but we want to trace back actually what's the logic of the changes. So that's why we use the Hyperledger Fabric and then put all these changes, all the comments, etc., on the blockchain. And then we also have a lightweight blockchain. So we call that a lightweight blockchain as a service, so LBAS. And with that one, then we have a whole workflow and integrate with Beam. Then we first of all have the transaction and then upload and query. So all these actions have the blockchain, and each kind of transaction have the corresponding data structure. And we tried this one in some projects, and we found that actually if we use the blockchain typically, then we will spend more time, but actually using our architecture, the lightweight one, then actually it saves time or even a shorter time than a typical platform. We also apply this one to e-tendering, because we always want to make sure that all the submission will have the timestamp and cannot be changed. And it actually adopts the irreversible nature of blockchain. So we apply this one to lead tendering system, and then this is the workflow, and then we actually select which are the important processes that need the blockchain. And then with this one, then we actually look at what will be the approval, what will be the submission, and then with this kind of workflow, then we have the corresponding smart contract. And then we put all this data, and then we also define the corresponding data structure to support this one. And with this one, then we have tested with different scenarios, and these are some of the scenarios that we have tested. We also have worked on the project document versioning management. So this is a project that we work with a contractor, and we found that for a contractor during the construction, they keep having the changes. And then, for example, we work with a project at the Kelly Sports Park, and then we use the example as the scenario, and then they deal with a lot of contractors, subcontractors, etc., and they have the dependency on the projects. So first of all, we need to consider what are the dependency, and then also what will be the corresponding data signature that we should keep in the blockchain. And then we also have another part, which is the issue management, and then we put all these comments in the blockchain. And so basically, we first of all need to understand the dependency logic. For example, all the architectural model would be the basis for structural, and then MVP would need to depend on the structural and architectural model. So it means that if we have a design, MVP design based on the old version of the architectural model, then basically this should not be even uploaded, because it will be wrong anyway, because a newer version of the architectural model is already there, but you still have designed according to the old version. So that's why we also keep track of all this dependency, and the actual dependency in a real project is more complicated, because they also have the facade and then many subcontractors, etc. Then we define all this dependency in a network, and then apply this one in the platform. We then have a smart contract to automate all these processes. And then with all these, then we also define the blockchain models. And then, for example, for issue records, then what is the data structure? For example, for file upload record, what's the data structure, etc. So we put all these, and then we can standardize. And hopefully, then this could be one example. And then in the future, we can kind of give a good reference for blockchain or secure the versioning or document management platform. And as I mentioned, we applied this one with reference to the Kelly Sports Park project. And basically, we have the so-called the multi-branch structure. The logic of this one is that, first of all, we have the version update. If there's any version update, it will initiate the smart contract, and then we will trigger the approval, stuff like that. And basically, then we have this kind of the multi-branch. Basically, is that every model will have its own model branches. So it's a different version. And then we also consider the dependency of that, so that it actually become a chain of the models. And then this chain of the model will need to depend on the previous model, and also automatically check it is the latest or not, or whether it's correct or not. If not, then cannot allow the upload. So it can make the blockchain become smarter, so that we can not only make sure that it's blockchain, but also upon the blockchain, it already have some kind of the checking. And then we found that with this kind of platform, then we can save about 20% of the time, so that it's also accurate and also more efficient. And then we also have a prototype like this. So first of all, for actual project, then the models need to go through different kinds of approval. For example, responsible, accountable, etc. They also need to do the signature. So we actually have this kind of the e-signature, so that once they sign, then they will know what kind of the document has got the have signed, and then we can also trace back all this information. And then actually at the back end in the blockchain platform, then each upload, each action have the corresponding the record, the transaction in the blockchain, the record. And then we also apply this one for carbon footprint tracking, because we found that right now we have the increasing the interest or increasing need for the carbon auditing for project, etc. So one thing is during the whole project. Second thing is about the material. We also want to trace whether the material, what will be the embodied carbon, etc. So we developed this prototype platform to do the carbon auditing based on blockchain. So basically, first of all, we have the decentralized blockchain platform, and then later, then we also preserve the privacy. So this one adopt the concept that I just mentioned, is distributed, and then they share the same chain in the platform. And then with this one, then we also keep the privacy. So basically, when they share, then part of the data will be public, but part of data will be encrypted, and then so that some private data will be secure, so that I can only know that, oh, the data actually have been shared, but some very sensitive data. For example, maybe the actual consumption, then maybe I don't want to share to all the suppliers to know, then I can still feel comfortable to share, because I know that the one who they basically is the access control with the blockchain the technology. And with this concept, then we also apply to cost management, because for cost management, we also want to make sure that some data will be secure, some data will be transparent. So basically, we have developed a cost data model, and also we make sure that, for example, we can share the data. Only some data will be transparent, but some data, you need the key to open that. And with this one, then first of all, we developed the data model for the cost information, and then we apply this one for the smart contract according to the workflow. And then this is an example of the cost information that we share. So as I mentioned, it will only be partially transparent. So we need to first of all define what will be transparent, what will not be transparent. And then with this one, then we also face the problem about the access control, because for example, I mentioned about some data will be encrypted. But when encrypted, then we found that, for example, if in a project, we always have new members. So when I have a new members, I want the new members to also get access to the data. For encryption, then we need the key. For example, I give you the key, then you have the key, then you can open that one. But if I have a new member, then how can I share the key to another new member? Because the new member will have its own signature. So now, if one way is I may decrypt that and encrypt again, considering the combined key, but this action may be risky, because if once I decrypt, then there may be some risk already. So instead of I decrypt and re-encrypt using the combined key, then we can have mechanism that we can re-encrypt, okay, re-encrypt without the need of the decrypting. So this one is something that can make sure that the data is always in the state of the encrypted manner. So this also allow combined key without the need of the decryption. So this is something will be helpful not only for cost. This is only for illustration, but also for other applications, similar application. And for this one, then as I mentioned, it can also apply to like payment, because for interim payment, we also want to make sure that, for example, the subcontractor may sometimes wonder, how comes I don't get the payment? So how about other subcontractor? Have other subcontractor get paid yet? So I want to keep the transparency that the status of pay or not pay will be transparent, but the actual amount paid will be encrypted, will be a secret. So in this kind of the partial encryption or partial transparency, then we can make sure that we can encrypt part of that, and then without the need of the decryption. So in this case, then we can know that, oh, actually, as the main contractor already have paid other subcontractor, but I don't know the actual amount. So this kind of way can help the project management. And then with this one, then we apply this one to smart contract for that. And for the whole thing, then all the way we can do it for the facility management. So for facility management, then we need to consider, for example, which kind of data will be sensitive. So particularly, for example, like maybe some sensor data, maybe the big boss room, the usage of the big boss room will be secret. So maybe I don't want people to know whether the big boss is in office or not in office, okay? So sometimes I also have this question, whether my student will check whether I'm in office or not. So, so that's why maybe some of the data or even floor plan, etc., will be, the secret information. So we apply this one to building. So with the help of one sponsor, Citibank, and then they have a commercial building. We develop a open beam platform, and we do it as a digital twin. So we use blockchain to secure all the sensing data, and then we can illustrate this one. So basically, this one is a platform that we develop as a prototype. We have the open beam platform, and this is based on IFC, and then we connect with the BMS, and then for some changes, then this actually connect to the blockchain. So the blockchain keep track of the sensing data. We also even apply this one to some temporary structure, temporary project. So I think all of us have experience about the COVID. And in Hong Kong, we have some isolation treatment facility. So this is one example. And then for design of that one, then it faces a few challenges. For example, whether the drawing will be transparent, or would there be inconsistent communication, or maybe the approval may be not well documented. So that's why we want to have the blockchain platform to satisfy all these principles. In short, then basically we try to use blockchain and then keep track of all the design changes, and also with all the permission, etc., approval, something like that. So we develop our workflow and compare this one with the existing one, and we find out that the efficiency actually is increased. So as a summary, then I have shared with you briefly about different examples of the use of the blockchain throughout the whole life cycle. So this also opened up many discussions about in the upcoming sessions, where or how we can use the blockchain for different applications. And then what I've shared is only about the concept and also the technology. But later in other presentation, they also talk about like the actual maybe infrastructure development, or maybe the legal concept, etc. And I want to recap about at the very beginning, I mentioned about the digitization roadmap by CIC. So because of that, so after sharing of all this application, then yesterday I also mentioned this one. Throughout the whole construction life cycle, what I mentioned is only some of the tasks. In fact, throughout the whole life cycle, we need to do a lot more. For example, in feasibility study, or maybe the inspection, or even the handover, many things. So for all this, how can blockchain technology be applied? And also, is it something about technology? Is it something about infrastructure, something about legal, or something about strategy? So all these will be addressed in the following presentation. So again, welcome all to the conference. And that's why in the following, we will have 8 sessions in different topics, and chaired by different keynote, different very well-known, very old expert in this blockchain platform. So without further ado, then I would like to thank all of you once again. So thank you all the sponsor, the supporter organization, keynote speakers, paper speakers, session chairs, guests, and participants. And without you, then this conference cannot be successful. So thank you once again, and I hope you enjoy the rest. Thank you.